Hello everyone. I welcome you all to the online broadcasting under NB Navale Hangar College of Engineering Solapur. Myself Professor Amiz Badegar, acting as an assistant professor in Department of Civil Engineering. I have completed my masters in civil structures with a teaching experience of 12 years. So in this session we are going to see the design of turnout in railways. Briefly speaking, we are going to discuss first of all the terms, the parameters that are associated with the design of turnout. Then we are going to see the numerical based on the design, and finally we are going to solve the assignments that are based on the bit. So starting in this slide, you can see a layout of a right hand turnout. Line diagram is shown with details, as well as on the left side you are having the design terminologies which are associated with the turnout. So let us see. First of all, a turnout is a arrangement of two tracks in such a way that the train changes its direction from one track to another. So while changing the direction, the two tracks converge with each other, forming a crossing. This includes, first of all, the crossing angle. So here if you see the first term that is related to the design, it is the crossing angle, and it is denoted by alpha. So here it is the inclination subtended between the stock rail and the tongue rail, and it is called as angle of crossing. Second one is called as the switch angle. So here if you see the starting point of the turnout, which is also a tangent point between the tongue rail and the stock rail, its inclination at the start is called as switch angle, that is beta. Third point is lead of crossing, or it is also called as lead. Now here lead is the horizontal distance. Again it starts from the tangent point and it ends to the theoretical nose of crossing. So whatever is the distance between these 2 points is called as the lead. Then fourth point, it is heel divergence. So here you can see there is a block provided in between the tongue rail and the stock rail. So this block is called as heel block, and whatever distance along the vertical direction of the heel block is called as heel divergence, that is also called as heel clearance and denoted by D. The fifth point, it is the straight arm. So straight arm, so when you consider the turnout along the curve from the tangent point to the theoretical nose of crossing, so appears to be a curve. Now from the theoretical nose of crossing to a distance x, this much distance, it appears to be a straight along the curve. So that part is called as straight lever arm and denoted by x. As well as here the inclination subtended is alpha, because these are alternate opposite angles, and the vertical ordinate formed here is x sine alpha. So that is regarding the straight arm. Now after that, it is the radius of turnout. So radius of turnout, there are two types. One is the radius for outer curve, second one it is for central curve. Here you can see R0, it denotes the radius for the outer curve. that is exterior turnout. Then an imaginary line that is passing through center of the track here. So the radius subtended by this arc is denoted by R, which is the radius of central curve. And last one is the gauge length. So that is the inner face distance between the two rails, and that is depending upon the type of rail or type of track, that is broad gauge, meter gauge and narrow gauge. So this is the brief explanation of the turnout. Now let us see one by one how to determine each parameter. So first of all, here it is crossing angle alpha. So there are three methods to determine the crossing angle. One of them is by Cole's method. In this method, a right angle triangle is considered starting from the apex point, that is theoretical nose of crossing, and to a distance horizontal n, which is the number of crossing. Here the vertical height, it is the spread between the stalk rail and the tongue rail that we have seen initially in the slide. Here the angle subtended at the T and C, that is crossing angle, and to determine it we have the formula, that is tan of alpha is equal to spread between the stalk rail and the tongue rail divided by number of crossing. So here you get alpha as tan inverse 1 upon n. So this is regarding the crossing angle. Now next on we'll move to the switch angle beta. So again here at the tangent point the sine beta is considered for calculating the inclination, and its ratio, it is heel divergence to the length of the tongue rail. Heel divergence, it is d, length of the tongue rail, it is lt. So by using this equation one can determine the switch angle beta. Below that, for a broad gauge track the standard values are taken, that is for heel divergence 13.3 centimeters and length of tongue rail 4.72 meters. The 100 is the multiplying factor for converting it into centimeters. So the final value here for beta, it is 1 degree 36 minute and 53 second. So that is the second parameter related to the design of the turnout. Next, the determining the radius of turnout. First of all, r0, that is the radius of the outer curve. So it is having the empirical equation, the gauge length, a ratio of gauge length minus heel divergence minus the vertical ordinate x sine alpha divided by cos beta minus cos of alpha. So this value will give you the radius of outer curve r0. Then for the central curve r is equals to the radius of outer curve minus gauge length divided by 2. So that is the straightforward equation. So the central curve radius depends upon outer curve radius, and here condition is given that when straight arm, that is x equals to 0, the second condition that may arise. So r0 will be given by the gauge length minus heel divergence divided by cos beta minus cos alpha. So from the above equation the x term vanishes as it is 0, and you will get the second condition, that is r0, radius of outer curve. And lastly we are having the equation for lead of crossing L, and it is given by the gauge length minus the heel divergence minus vertical ordinate x sine alpha into cot of alpha plus beta by 2 plus horizontal ordinate x cos alpha. So this is when the straight arm is present, when you are considering the value of x, and when x is 0, the lead of crossing works out to be the gauge length minus the heel divergence into cot of alpha plus beta by 2. So these are the parameters that are required for designing a turnout. Let us see in terms of examples. We'll consider both the cases for design of turnout. Now here, first numerical. On a broad gauge track, the straight arm for turnout is 85 cm and the crossing number is 8.5 and heel divergence is 11.43 cm. Length of the tongue rail is 4.7 meter. Determine radius of turnout and lead of crossing. So in this question, you can see it is a broad gauge track with a straight arm 85 centimeters. So here the value of x is given and number of crossings n, capital N, it is 8.5, heel divergence 11.43 centimeters and length of tongue rail 4.7 meters. So that is the given data, and each and every data is converted into metric, that is meters. You can see below there. Let's see its solution. First of all, determining the crossing angle alpha by the equation Cole's method. Tan alpha is equals to 1 upon n. So after substituting n is equals to 8.5, you get alpha as 7.45 degrees. Secondly, the switch angle beta. Its equation is sine of beta is equals to heel divergence upon length of the tongue rail. So after substituting the values, you get beta as 1.54 degrees. Next, radius of turnout r0. Its equation, that is gauge length minus heel divergence minus vertical ordinate x sin alpha divided by cos of beta minus cos of alpha. Substituting all the values, we get r0 as 223.31 meters, that is radius for outer curve. Now from that value we can determine the radius of central curve, that is r0 minus g by 2. So here it works out to be 222.47 meters, that is radius for central curve. And lastly, calculating the lead of crossing. L is equals to, the formula is written, substituting all the values, the gauge length, heel divergence, straight arm, alpha and beta, we get the lead of crossing as 21.526 meters. So this is the total solution for determining the radius of turnout and lead of crossing for case number 1, that is where the value of x is given. Now second one, considering second problem where the straight arm is 0. The question is calculate lead and radius of a 1 in 8.5 broad gauge turnout for 90R rails using Cole's method. Take width of broad gauge 1676 mm, heel divergence 120 mm and alpha 6 degree 42 minutes 35 seconds. Again here the lead of crossing and radius of turnout is asked. The given data is somewhat similar. Here alpha is given the value directly 6 degree 42 minutes 35 second, as well as the value of n is given in terms of slope, that is 1 in 8.5. So that is nothing but the ratio of 1 upon n. So by using Cole's method, if you take tan inverse 1 upon 8.5, directly you get alpha as 6 degree 42 minute 35 second. So there is no need to calculate alpha separately. Now switching on to switch angle beta, taking the formula, that is sine inverse of ratio of heel divergence to length of the tongue rail. Here the length of tongue rail is not given, you have to assume it 4.72 meters for broad gauge. So switch angle works out to be 1.60 degrees. Secondly, the radius of turnout. Now here you can see in the equation of r0, the value of x is 0. So the equation turns out to be the ratio of the gauge length minus heel divergence to cos beta minus cos alpha. After substituting the values, you get r0 as 318.06 meter, that is radius for outer curve. Now radius or central curve, that is r is equal to r0 minus g by 2. So here you get the value of radius as 317.22 meters, that is radius for central curve. And finally the lead of the turnout, again here you see there is no term related to x. So L is equals to the gauge length minus heel divergence into cot of alpha plus beta divided by 2, which finally works out to be 1.456 meter. So that is the lead of crossing. So that completes the second type of numerical, which is without considering straight arm. Next, the assignment that is based on the turnout and crossing, assignment number 5. There are 5 questions given here. 4 are the theoretical one is the numerical one based on design. That is the assignment. All the questions are taken from the university paper. I think this has given the brief explanation regarding the design of turnout, the different parameters, and the numericals based on the turnout, and hope everyone will consider and solve the numerical and assignment without fail. Thank you. Thank you.